Dear students, let us begin with our second part of the lesson. We will learn about computation of expected frequencies using model fitting and probability distributions. Chi-square test is a statistical test used to determine if there is a significant association between two categorical variables, or to test the goodness of fit of observed frequencies to expected frequencies under a specific distribution. Here you can frame your H0 and H1, that is your null hypothesis and alternative hypothesis, as there is no significant difference between observed and expected frequency. Then automatically your alternative hypothesis will be framed as there is a significant difference between observed and expected frequency. So as I mentioned in our previous lessons, the significant difference will mean that discussion on the statistic and population, whereas here it will be on observed and expected. If there is any differences, it is due to the population. Now coming out to the computation of expected frequencies, chi-square test determines if observed frequencies of a single categorical variable differs significantly from the expected frequencies under a specified distribution or model. Here you can go with different types of distribution, where it may be chosen as an binomial or it may be an Poisson. Any type of distributions can be chosen to identify the chi-square test here. To compute the expected frequencies, we assume a specific probability distribution or the model for the variable. Now coming out to the computation here, for example, if you have a categorical variable representing eye color with observed frequencies, then we might assume a model where the expected frequencies will follow a certain distribution, such as it should have equal probabilities in a certain population. Usually if you choose any distribution, you should be mean with your probabilities here, and also assuming with the equal type of probabilities here. Now coming to the computation here, you can calculate the expected frequencies based on the assumed distribution or model. The formula for expected frequency of a category is the total sample size multiplied by the probability of that category under the assumed distribution or model. In whatever the distribution you are getting, it may be a binomial or Poisson, you will be defined with a probability mass function, or you can call it as a probability function. With that probability function, you can substitute your various expected values and you can move on with your calculations, whereas you can multiply with your probability with your total frequency and you can obtain your expected frequencies. That is, let you are having the values as x as 0, 1, 2, 3, where you can substitute them into your probability mass function. Then you can obtain your expected frequencies by multiplying the total frequency. For example, let us consider a scenario where we have a categorical variable with three different categories A, B and C. The null hypothesis assumes that the expected proportions for these categories under a binomial distribution are 0.3, 0.4 and 0.3 respectively. If we have a total sample size of 100 observations, that is our total frequency, we can calculate the expected frequencies as follows. That is, as earlier mentioned, that by multiplying this value towards your percentages, where you can obtain your expected frequencies. Now I can see in a category A here, your expected frequency can be calculated with 100 into 0.3, that is 30. That is 30 will represent your expected frequency for your category A. Similarly for category B, expected frequency will be 100 into 0.4, which is 40. At the end, the category C will be the expected frequency 100 into 0.3 will be 30. Here not mean that the 100 is a fixed number, the sample size will be differed. Sometimes you may be having a sample size of 150 or 200, whatever may be the number. Based upon that your sample size, you will be calculating your expected frequencies. Once the expected frequencies are calculated, we can compare them with our observed frequencies by using the chi-square test statistic. Whereas to determine the significant difference between them, you are using this chi-square test statistic, that is your OI and EI, that is your observed frequency and expected frequency. Based on the distribution, the data has to be fitted properly to obtain the probability value for each observed frequency. Usually if you are going for an binomial or Poisson or normal, whatever may be the distribution, the fitted form will speaks about the accuracy, how it has been working. So with that part you can go for your calculation of observed frequency and expected frequency. Thus to obtain the respective expected frequency, you can multiply the above probability with the total sample size, which we done in the earlier case. Now we can go for some example here. Accident frequency. Usually know that the frequently getting number of accidents in a day has been increasing. Now we can see with an example here. Suppose you want to investigate whether the number of accidents per day at a particular intersection follows a Poisson distribution with a mean of 3 accidents per day. So for your reminder, Poisson distribution is a distribution which collects the information on the rare events. Where the happenings are rare, it can be considered, whereas here the accidents has been chosen under the category of Poisson distribution. As you know that the Poisson distribution will have a parameter as lambda, mean and variance will also have the same value as lambda. That is, the 3 will act as the mean, the 3 will act as the variance, 3 will act as a parameter for the Poisson distribution. You can collect the data on accidents over a period of time and count the number of accidents that occurred each day. You can compare them observed frequencies with your expected frequencies based on the Poisson distribution to see if they match or not. That is, by using your probability mass function of your Poisson distribution, you can substitute your collected data in that and you can multiply them towards your total frequency and you can obtain your expected frequency. Similarly, you can go with one more example. I have been introducing an website traffic. So the website traffic is nothing but particular websites or particular site has been visited a lot number of times. So you can see that during in April and May, the admissions, that is the universities and the colleges websites will be in an website traffic. That is, everyone will be visiting the website and they will be looking on where to study or where to join, they will be having it. You can see over here, suppose you are studying website traffic and want to determine if the number of page views per hour following a Poisson distribution with a rate parameter of 10 pages per view. That means 10 pages, it means automatically you can mean that it is a parameter, it is a mean, it is a variance, whereas for the Poisson distribution all the 3 will act as same. You can collect the data on page views over multiple hours and calculate the observed frequencies for different number of page views. Not only with this website traffic, you can also use it as an YouTube likes or YouTube subscriptions. You can see it in a calculation how it has been running for past a day, how many number of likes has been obtained, or past a month how many likes has been obtained. You can see over those cases where you can study about the website traffics, where you can see some over during a time there may be having a peakedness, later it may be decreased. As I mentioned in an example, during an April and May, the college websites or university websites may be in a peak, that is the more number of visitors may be there. Then there may be an lesser strength later. That means website traffic will be changing based upon the time, or it may be on the cases. You can also go with 2 more examples here, not only with the website traffic here, you can also move on with an medical type of examples. Usually we have an habit of taking a medicines, or it may be taking an injection, where it will be getting an bad reactions will be an very less probability. That is, you can say that the happening will be very rare. The Poisson distribution will collect wherever the situation has been happening as an rare, it will concentrates. Where you can see it an medical pattern, that is the medicine or injection will be treated it as an less probability to have a bad reaction. In a similar fashion, you can also move on with an incoming calls towards a phone, where it can be taken it as an rare cases. At the same time, once you have been getting with a one call, you may not be getting within the other, where you can be blocked with the other one. It means that you may be moving towards your rare type of situations. Now we are in the end of part 2 of this lesson. In this part we have been learnt on the categorical variables, calculation of expected frequencies through fitted distributions. I am confident that you understood all the concepts. We will continue in the next video. Thank you.